SIT 210 task 5.1. So, in this task, we were asked to blink the LED through Raspberry Pi. So, before this task, you need to complete the Raspberry task 4.1, where we are required to set up the Raspberry Pi for other tasks. So, in this task, we have to define a Python code for programming language and which is most comfortable with Raspberry Pi. So, to perform this, we will define a Raspberry Pi code and the hardware setup. So, now let's jump into the hardware setup. This is the hardware setup of tasks 5.1p. So in this task we were given to blink a LED using the Raspberry Pi. So this is the Raspberry Pi board and this is the setup for the LED blinking. So here we have used one LED and one resistor. We have used one resistor in order to prevent the hardware from burning due to overload of current. So now let's connect the LED pins to the board. So we have connected the LED pin to GPIO 10 and ground as per the code we are using. So this is the final setup for the hardware. Now let's jump into the code explanation. So this is the hardware code for the our RPI. So first command is import RPI as GPIO. So this command imports the RPI GPIO library and assigns its allies to GPIO to make it easier to the work. So the next line is import time. So this is a time module which is implemented in the task in order to create time delays in the program. So now let's come to the setup part of the pins. So we have used the function GPIO set mode. So the set mode function sets the pin numbering mode for the GPIO library and it sets its use as to use the physical pin numbers on the Raspberry Pi board. So now we have used the setup function to set the GPIO board pin 10 as an output. Now later on this function configures the pin 10 as the output pin and prepares GPIO pin to send out signals to control LED for some other device. So later on we have used the try function. So this line starts a try block indicating that the code inside the following indented block is subject to exception handling. So there is a while loop. So the line starts an infinite loop and the condition 1 always evaluates to true. Therefore, so the loop will run infinitely until and unless it is interrupted. So there is GPIO output. So the output pin will become high and it will remain high for 0.25 seconds as we have implemented a sleep function. So this function provides a delay for the pin to blink for 0.25 seconds and later on we have declared this pin as low. So and after 0.25 seconds it will become low, so it will blink for 2.5 seconds and 0.25 seconds and later on it will turn off. So this will keep on repeating until and unless we will interrupt the code. So next come to accept hardware accept keyboard input. So this line starts an exception for the handler specific for the keyboard exception. So this exception is raised when the user presses Ctrl+C in the terminal, allowing the program to gracefully exit. So with this, the GPIO will clean up and the interrupt is raised and the line will be executed. So this line will clean up and release the GPIO resources, ensuring that the GPIO pins will return to their default state. Because we have used the pins in the output state and it will make the pins ready to use for another program and make them in their default state. So this was the code for the RPA. Now let's jump into the working part of the code.